Hello, and welcome to this video. As you might know from the previous videos that we are going through the standard library of vectors. So we are here at as chunks. We are nearly halfway through the documentation, and let's see how much remain. Okay, quite a bit remains. So okay. Yeah, quite a bit. It might take another 5, 6 videos. So, yep, lots of stuff remaining. So, we go here. So, be patient. There is no shortcut to learning the language in detail. You have to go through the documentation. There are no shortcuts. So, as chunks takes an argument. Okay, this is the size. All right. So, splits the slice into a slice of an element array starting at the beginning of the slice and the remainder slice with length strictly less than n. The remainder is meaningful in the division sense. Given left chunks from a remainder equal to slice dot as chunks, then chunks dot length equals slice dot length divided by n. Remainder dot length equals slice dot length percent n, and slice dot length equals chunk dot length times n plus remainder dot length. We can flatten the chunks back into a slice of T with n flattened, which panics if n is 0. Note that this check is against a constant parameter, not a runtime value, and thus a particular monomorphization will either always panic or it will never panic. So we have slice here, LOREM, and we take chunks and remainder. So you see there are 5 characters and 2 times 2 will go in chunks and n will be available in the number. If you expect the slice to be an exact multiple, you can combine let else with an empty slice pattern. So here we let chunks comma empty array, slice is left, slice dot as chunks 2, else panic, slice did not have even length. And when you assert chunks, you will have 2 slices RU and ST. Then we have as R chunks, similar to F chunks. Split the slice into an element array starting at the end of the slice and the remainder slice with length strictly less than n. The formulas are similar, panic is similar. So suppose we have lorem, then in this case, remainder would be L and chunks would be OR and EM. Then we have as underscore chunks underscore unchecked underscore nut. So it takes a mutable slice and gives a mutable slice. Splits the slice into a slice of n element arrays. Assuming that there is no remainder, this is inverse operation to as flattening mutable. As this is unsafe, consider whether you could use as chunks mute or as r chunk mute instead. Perhaps for something like if let chunks comma empty array is equal to slice dot as chunk mute, or let chunks comma empty array slice dot as chunks mute else unreachable, and then we have unperturbed. This may only be called when the slice splits exactly into n element chunks, also known as self dot length percentage n is equal to 0 and n is not equal to 0. So we have the slice of a vector array. We have LOREM exclamation mark. So we split into chunks of 1. So we have slice dot as chunks and nut and unsafe. And chunk 0 would be capital L. We set it to be capital L. And then chunks is LOREM exclamation mark. And then we chunk it by the size of 3. and we put chunk 1 as a x question mark, then the slice would be LOR AX question mark. Then we have as chunks node takes M as an argument, not really an argument. Okay, it is a generic parameter, and then it takes an itself. And returns immutable stuff. One will be chunk, another will be remainder. Splits the slice into a slice of n element arrays starting at the beginning of the slice, and the remainder slice with length strictly less than n. The remainder is meaningful in the division sense given like chunks comma remainder is equal to slice that as chunks node. Then mathematics is what we have as chunks, and flattening is similar, and it is also similar. So suppose we have a mutable vector of 5 zeros, now let count is equal to 1, then as chunks mutable we split this into chunks and remainder, and remainder 0 will make it 9. And for chunk in chunks we create a chunk of 2, okay? So from the count we take 2, okay, and we add the count here. So our vector is now 1, 1, 2, 2, 9. So this count initially would be 1. But count is 1 here, and we put 2 elements here in the chunk. So 1, 1 comes, then count increases to 2, and we get 2, 2 here, and finally remainder as 9. So our V becomes 1, 1, 2, 2, 9. Then we have our chunk node, similar to as chunk nodes, but in this case, since it is R chunks, 9 will come at the beginning. We put it at the beginning, not at the end. Then we have array underscore windows, takes a generic parameter n of size type and operates on self. Returns an iterator over overlapping windows of n elements of a slice starting at the beginning of the slice. This is the most generic equivalent of windows. If n is greater than the size of a slice, we will return no windows. And it's a similar. So our slice is 0, 1, 2, 3 here, and we get a mutable iterator slice dot array windows. So the first iteration will give us 0, 1, the second will give 1 and 2, and third will give 0 and 3, and then it will return 1. Then we have R chunks, takes a size and operates on self and gives an R chunks type return value. Returns an iterator over chunk size elements of the slice at a time starting at the end of the slice. The chunks are slices and do not overlap. If chunk size does not divide the length of the slice, then the last chunk will not have length chunk size. C R chunks underscore exact for a variation of this iterator that returns chunks of always exactly chunk underscore size elements and chunks for the same iterator but starting at the beginning of the slice. If your chunk size is a constant, consider using as R chunks instead, it will give references to arrays of exactly that length rather than slices. So our slice is Lorem here. We do our chunks and get an iterator of size 2, and then our slices would be EM, OR, and L. Note that the slices do not overlap here. Last time we got 0, 1, 1, 2, 2, 3, so slices were overlapping, but here they are not overlapping. Okay, and finally we will return none. Then we have R chunks mutable, so it is similar to R chunks, but the slices will be mutable this time. So see, we have 0, 0, 0, 0, 0, and we do the single logic which we encountered earlier. We get here 1, 1, 2, 2, and then 3. Then we have R chunks underscore exact. Returns an iterator over chunk size elements of the slice at a time, starting at the end of the slice. The chunks are slices and do not overlap. If chunk size does not divide the length of the slice, then the last uptick chunk minus 1 elements will be omitted and can be retrieved from the remainder function of the iterator. Due to each chunk having exactly chunk underscore size elements, the compiler can often optimize the resulting code better than in case of R chunks. C R chunks for a variation of this iterator that also returns the remainder as a small chunk and chunks underscore exact for the same iterative but starting at the beginning of the slice. If your chunk size is constant, consider using as R chunks instead, which will give you references to arrays of exactly that length rather than slices. In Panic if chunk size is 0. So our slice is Lorem and our chunks underscore exact splits this into two. So you get EM first, then OR first, and then none. And remember in this case would be L. So that you have to explicitly invoke to get the remainder. Then we have R chunks mutable, similar like R chunks exact mut, similar like R chunks exact, but in this case, it will give us mutable arrays, right? So here we do the similar logic. Our values are 1, 1, 2, 2, and 0. Then we have chunk by, which takes a predicate. The predicate would be a mutable closure, returns a boolean. Returns an iterator over the slice, producing non-overlapping ones of elements using the predicate to separate them. The predicate is called for every pair of consecutive elements, meaning that it is called on slice 0 and slice 1, followed by slice 1 and slice 2, and so on. So here we have 1, 1, 1, 3, 3, 2, 2, 2 as this slice. Now our chunk by logic is it takes two elements and compares for equality. So we do the iter next here, and we see that it returns this iterator returns 1, 1, 1. Okay, and then it returns 3, 3, and then it returns 2, 2, 2, and finally it returns none. This method can be used to extract the sorted subslices. So here we, in the closure, we compare A less than equal to B. So we get 1, 1, 2, 3 here, and then we get 2, 3, and then we get 2, 3, 4. So the condition that A should be less than B, the raised left element should be less than the right element, and that many elements will be returned by chunk. Then we have chunk by mut, similar, but this time we get mutable arrays or slices. So similarly, we have the example, then we have splitter and takes an argument we make, divides one slice into two at an index. So first will contain all indices from 0 to m, typical half closed, half open interval, excluding the index made itself. Whenever we see array, it is usually half closed, half interval. On the left side, it will be closed, that is including that value. On the right side, it will be half open, that is, it does not include the value. And the second will contain all indices from mid to len, excluding the index len itself. It panics if mid greater than len. For a non-panicking alternative, you split at chunk. So we have vector ABC and we split at 0. So left is basically empty and right will be ABC. Then we split at 2. Left would be A comma B and right would be C. And then we split at 3. Then left would be ABC and right would be empty. Then we have split underscore mut, which will be similar to split at, but in this case, both the parts will be mutable in this case. So left would be 1, 0, and that would be 3, 0, 5, 6, and you can assign to left one, right one, and all that. And you will see that those are reflected in the final vector. Then we have split at unchecked, divides similar things, but it is unchecked. Following this method with an out of bounds index is undefined error, even if the resulting references is not used. The caller has to ensure 0 less than equal to mid, less than equal to mid self-plan. So since it can panic and it doesn't do bound checking, it will be slightly faster as well. So we have split at unchecked 0, so everything goes into right. Then similar stuff, nothing different. Just note that we have to put them in unsafe block now. Okay. These were case functions, so you didn't need unsafe block here. Then we have split at mut unchecked, similar to mut check, but this time they will be mutable. Okay. So similar stuff. Split at check. So this time bounds will be checked. Divides one slice into two at an index returning none if the slice is too short. If mid less than equal to none, returns a pair of slices when where the first will contain all indices from 0 to mid. and the second will contain all indices from mid to len. Otherwise, if mid greater than len, returns none. So we have split at 0, and we see that everything goes into right. When we split at 2, then we get 1 minus 2 in the left, and right we have 3 minus 2, 4, and minus 6. And then we split at 6, we get everything into left, and then right is empty. And finally, if we try to split at 7, where mid will be greater than or equal to length, then it will return none. Then we have split at mid and check similar stuff, but what it returns is notable now. Okay. Then we have split, takes a predicate, which is a notable closure. So returns an iterator over sub-slices separated by elements that match predicate. The matched element is not contained in the sub-slices. Okay, so observe that the matched element is not contained in the sub-slices. So split, and we have num percentage 3 is equal to 0. So 10 and 30 will not be divisible by 3, so they will go into the first unwrap, first next call of iterator. And 33 will not be included, and then we will have 20. And finally, we have none. If the first element is matched, an empty slice will be the first item returned by the iterator. Similarly, if the last element in the slice is matched, an empty slice will be the last item returned by the iterator. So we have 10, 40, 33, and this time 33 will match. So the second call of next will give us an empty item. If two matched elements are directly adjacent, an empty slice will be present between them. So here 6 and 33 match. So after 10, we get empty slice here. So 10 is the first item, it did not match, these two match, so we have an empty slice after that. And then after that, we have 20. Then we have split mode, same stuff, but this time the slice will be notable. So we get groups here, and we put group is equal to 0. So you see 10, 40, so 10 will become 1. And then 30 will match, so 20 will be the next group, 26, 20 will be the next part of the slice. So it will become 1 as well. 60 will match, and it will not be selected, so it will remain empty, and next one will be 50, it will be again made 1. So this is our final result 1. Then we have split inclusive, which takes mutable and returns a bool. Another closure returns an iterator over subclasses separated by elements that match predicate. The matched element is contained in the end of the previous subclass as a terminator. So this time matched element will be kept in the left side of the slice. That is, the next call will contain the matching element. So we have 3 matches with 33. It is divisible. So 10, 40, 33 will be in the first one, and then 20 will be in the second one. If the last element of the slice is matched, that element will be considered the terminator of the preceding slice. That slice will be the last item returned by the iterator. So here 3 matches. So 3 is the first slice, then 10, 40 are in the second slice, but 33 matches. So it will be put into the last element of the second slice. Then we have split including mutable, similar stuff, but this time it is mutable, so we can change the code. And I think I will stop here. Okay. In the next video, we will resume at split. So I hope that you are enjoying this read through of Rust standard library documentation and learning a bit. So even if you are a seasoned programmer, knowing all of standard library by anyone is not possible, but you should be aware of what is available and what are the functionalities which are given to us. Otherwise, we will end up doing the same. So thanks a lot for watching the video. I'll see you in the next one after 4 days. Till then, enjoy and keep learning. See you around. Bye.